This question is from GATE 2025 Electronics and Communication branch, question number 54. Okay, and it has been asked from the subject communication systems on the topic random variables and entropy, and it's a 2 marks question. So I'm going to solve question number 54. Okay, the random variable x takes the values -1, 0, 1 with probabilities p of x is equal to -1 is equal to p of x equal to 1, and the probability value is alpha, and p of x is equal to 0 is 1 minus 2 alpha, where alpha lies between 0 to 1 by 2. Okay, let g alpha denote the entropy of x in bits parameterized by alpha. Then which of the following statements are true? So first of all, this is an MSQ question, multiple select question. Okay, so there are 4 options are given: option A, option B, option C, option D. Okay, here is the NPTEL reference. You can go through this lecture. Okay, so I'm going to solve this question. Solution. Okay, so given x is having outcome of a random experiment. Okay, x is having outcome of random experiment. So the entropy I am considering h of x will be maximum when the event occurs with equal probability. So this is a very important statement. So h of x entropy will be maximum when the event occurs with equal probabilities. Okay, so for maximum occurrence of entropy we need to find the probability which is like equal. Okay, so given p of x is equal to -1 is alpha, p of x equal to 1 is again alpha, and p of probability of x is equal to 0 is given 1 minus 2 alpha. Okay, so maximum entropy, so we need to equate all these, like I can equate 1 minus twice alpha which is equal to alpha. Okay, to find at what alpha values I will get maximum probability. Okay, so from this 3 alpha is equal to 1, so implies alpha is equal to 1 by 3. Okay, so I can write probability of x equal to -1 is equal to 1 by 3, probability of when x equal to 1 is also 1 by 3, and probability of when x equal to 0 is 1 minus twice alpha, so it will be 1 minus 2 into 1 by 3, so it will be 1 by 3. Now you can see all are equiprobable. Okay, so let me draw this curve. Okay, so in x-axis I have probability, and y-axis I have entropy. Okay, h of x. So I can draw this curve, and maxima happened at 1 by 3, or I can write 0.33. At 0.33 maxima happened. Okay, and rest points it is like reducing, it's like a bell shaped curve. Okay, now I need to check the options. Okay, so you can assume like this is 0.33. At 0.33 the entropy is maximum. Beyond this side or that side it is minimum, like it is decreasing in both direction, but maxima at 0.33. So let me check the option. So option A, it is giving g of 0.4 is greater than g of 0.3. Okay, so let me change the color. So 0.4 is lying somewhere else. Okay, 0.4 I am assuming here, and 0.3 is somewhere else. Okay, so obviously at 0.4 probability should be less, sorry, entropy value would be less, so this statement is wrong. Correct. Let me check the option 2 B. I can write option V. So option V, g of 0.3 is greater than g of 0.4. So g of 0.3, 0.3 is here, okay, and 0.4 is already here, so this statement is true. Okay, let me check option C, g of 0.3 is greater than g of 0.25. So let me check, 0.3 is here, okay, and 0.25 is somewhere here. So obviously 0.3 is greater than, this is my 0.25. So 0.3 is obvious greater, so this statement is also true. Coming to option D. Okay, so D, g of 0.25 is greater than g of 0.3. So at 0.3 near it is maxima, so 0.3 this value should be less than that, so this is wrong. So option D is wrong. Okay, one more thing I just want to clarify. So g of alpha, it is the entropy value, it gives entropy value. So these are the entropy values, this will give entropy values, and from the curve I am finding the values and I am considering like which statement is correct. So from this I can say option B and C, okay, both are correct. Okay, option B and C both are correct. So this option is correct as well as this option is correct. Okay, thank you.